Assalamualaikum warahmatullahi wabarakatuh. My name is Nuriman. So I would like to present about introduction of Rolle's theorem. So the Rolle's theorem appear when real valued differentiable function that attains equal values at two distinct points must have at least one stationary point somewhere between them. Okay, the point is the first derivative. The first derivative means the slope of the tangent line, and the slope must be equal. The function must be equal to 0 if we want to find the slope. Like on the slide, fa must equal to fb. So then there exists at least one number c in AB for which f prime c equal to 0. Like I said earlier, the function must be equal to 0 if we want to find the slope of the tangent line. Next, introduction of mean value theorem. Okay, so the mean value theorem, for a given planar arc between two endpoints, there is at least one point at which the tangent to the arc is parallel to the secant through its endpoint. Problem statement for Rolle's theorem. We read the equation gx equal to x power of 3 minus 4x plus 3 bracket 0 and 2. Okay, firstly we have to solve the gx by enter the intervals value to the equation. So then we have to find g prime c by differentiate x. Okay, we have to find c to satisfy the conclusion. And for problem statement for mean value theorem, first, like we read at the slide, fx is equal to 8x power of 2 minus 4x over x plus 2. Okay, so we have to use the formula f prime c equal to fb minus fa over b minus a. But before that, we must differentiate fx. We must differentiate fx and then use the formula.
Next we will move to solution, which is how to solve question for Rolle's theorem and mean value theorem. I will go for the first one, which is equation for Rolle's theorem. As we can see in this theorem, fa equal to fb, therefore it will be fb minus fa equal to 0, and then we will apply differentiation of fc equal to 0. From the question below, we need to find the values of c that satisfies the conclusion of Rolle's theorem. So the function that have been given is gx equal to x cubed minus 4x plus 3, and the interval is 0 and 2. We must know that both interval value is x value for gx functions. Then we must let 0 as a and 2 as b. Step 1. From gx function, replace x values to 0 as it will become g0. The same goes to interval value for 2, which replace it by x values in gx function. Then calculate them. So we get the same value, which is 3. From the step above, we can assume that g0 equal to g2. Next, we differentiate gx as we get 3x squared minus 4. Then we need to substitute x to become c. So we get gc equal to 3c squared minus 4. Then implies gc equal to 0. So we get 3c squared minus 4 equal to 0. From the equation, find value c, as we get the answer c equal to 1.1547. So this answer include in interval 0 until 2. Next, for the mean value theorem, it is same as Rolle's theorem, but the difference for this theorem is we will use derivative of a quotient of two functions. This theorem use formula fc equal to fb minus fa divided by b minus a. From the question, we must find the value of c, as the function given is fx equal to x squared minus 4x divided by x plus 2, and the interval is 0 and 4. First step, we need to differentiate fx, as we got x squared plus 4x minus 8 divided by x plus 2 squared. Then, from the formula for this theorem, replace all the function and value from x to c. Then, calculate first for f4 and f0, as we get the value is 0. Calculate the equation, and lastly, we will get the equation is c squared plus 4c minus 8 equal to 0. Then, find the values of c, which we get 1.464 and negative 5.465. For this answer, we only take c equal to 1.464 as it include in the interval. For c minus negative 5.464, there is no exist negative 5.464, which is point c in the interval 0, 4. So the final answer is c equal to 1.464 in the interval 0, 4.
Okay, in this video, I'm gonna tell you an example of the mean value theorem. What does this time mean? Using the time that it took for me to travel 1 kilometer, I can calculate my average velocity. We already know that. Okay, average velocity is equal to total distance per total time. And so, my average velocity can be calculated by doing average velocity is equal to 1.6 km per 52.91 second times to 3,600 seconds per 1 hour, and we can get the total of 108.9 km per hour. My original value was given in km per second, and so I had to multiply it by 3,600 seconds per 1 hour to get it in km per hour. A trucker travels 260 kilometers on a toll road with a speed limit of 110 kilometers per hour. The truckers complete the 260 kilometer journey in 2 hours. At the end of the toll road, the trucker is issued a speeding ticket. Why? Okay, well, since the truck's position is continuous on the closed interval, differentiable on the open interval, there was no discontinuities on the position graph. The truck passed through every point on the way from tool booth to tool booth. There were no wormholes or teleporters to create a hole, and a collapse in a position graph would not be fun if you were traveling at 70 miles per hour. I would not want to be in that car. The mean value theorem applies. The mean value theorem states that at one point, the average velocity of the trucker must be equal to the instantaneous velocity of the trucker. Since average velocity is equal to total distance, or you can say it displacement per total time, and 260 kilometers per 2 hours equal to 130 kilometers per hour. Then, at least once in time, while on the toll road, the tracker was going 130 kilometers per hour. Well, it's over the speed limit. So, how does the mean value theorem apply here? Since my position function over time in the car was continuous on the closed interval and differentiable on the open interval, a sudden change, a gaps, or a hole in my interval would be very troublesome. Again, there were no discontinuities on the position graph. The car went through every point on the miles, and I did not use any wormholes or teleporters in this experiment. Then, the mean value theorem applies to the situation, and since the mean value theorem states that there is at least one point along the interval where my instantaneous velocity is equal to my average velocity, this means that if my average velocity on the interval was 108.9 km per hour, then there is at least one point along the interval where my instantaneous velocity was 108.9 km per hour.
Assalamualaikum, my name is Muhammad Fadli. The conclusion for Rolle's theorem is that if the curve is continuous between 2 points, point A and point B, a tangent can be drawn at each and every point between point A and point B, and functional values at point A and point B are equal, then there must be at least one point between the 2 points which the tangent to the curve is parallel to the x-axis. So next, the conclusion for mean value theorem. This theorem states that if fx is defined and continuous on the closed interval a and b and differentiable on open interval a and b, then there is at least one number c in the interval a and b. In this case, we have fc equal to 0. In other words, there exists a point in the interval ab which has a horizontal tangent. In fact, the mean value theorem can be stated also in terms of slope. Indeed, the number using this formula is the slope of the line passing through point A, FA and point B, FB. So, the conclusion of the mean value theorem states that there exists a point C in the interval AB such that the tangent line is parallel to the line passing through point A, FA and point B, FB.